Components Corporation is the global leader in the design, manufacture, and engineering of precision printed circuit test points, interconnect and testing devices, printed circuit card edge connectors, pre-formed jumpers, hardware, and battery contacts. Visit us at www.componentscorp.com.
Welcome to Engineering Update. I'm Casey Panetta, Managing Editor of ECN. In this week's episode, a guide to charging your phone in 30 seconds, becoming a music lover, and deploying electromagnetic railguns. Despite the fact that we, as a species, really perfected the art of perfectly timing cell phone charges, being forced to wait several hours to get a full charge seems a bit, well, archaic. With that in mind, Israeli startup StoreDot is taking the lead on shortening the amount of time it takes to charge your phone from a few hours to about 30 seconds. Traditionally, recharging a battery takes time because it involves reversing the chemical reaction that caused the battery to deplete. In order to be both safe and efficient, this process takes a long time. But StoreDot created chemically synthesized bioorganic peptide molecules called nanodots that, as the name suggests, are really tiny. Their size allows for improved electrode capacitance and electrolyte performance. The dots are made from bioorganic raw materials, which are both abundant in supply as well as non-toxic, making the StoreDot nanodots inexpensive and safe to produce. This is interesting because other companies with similar technologies have traditionally been heavy metal-based, which makes them toxic. Though the applications for technology eventually include electric cars and larger batteries, the company demonstrated at Microsoft's Think Next symposium that the prototype batteries currently have the ability to replace an average cell phone battery. The company is planning for mass market distribution and dealing with technology patents, but they hope to have the technology available by 2016.
Last year, I actually paid money to see an opening band do this. Yeah, it was sad, but musicians are more often relying on computers, faders, knobs, and buttons to make music. While looking to move away from flitting behind screens and instruments, English musician Imogen Heap wanted something that let her expressively interact with her computer as much as she does with her piano. So she turned to the power of glove. Yeah, that's her pun, not mine. Heap reached out to the nerd underground, and after 4 years of development, her MIDI gloves have turned to crowdfunding site Kickstarter.com to help raise more than $330,000 to finalize glove design and ready them for production. Working with high-precision wearable sensor technology, the Mi.Mu gloves track hand motion, recognizing postures and detecting sharp movements. Air guitarists and drummers around the world rejoice. Each glove has a Wi-Fi-enabled XIMU board, developed by XIO Technologies, that has an accelerometer, a magnometer, and a gyroscope, which work in concert with a series of motion sensors woven into this e-textile to track how you bend and spread your fingers. The gloves are outfitted with lights and vibration to provide the user feedback and use open source software. This way, any user can program gestures specific to their application. You know, make their own sweet, sweet glove music, transforming that sad band I mentioned before into this.
The Navy always seems to get the coolest toys to play with. Lasers, Tomahawk missiles, autonomous countermeasure systems.
Where does it get those wonderful toys?
Earlier this week, the Navy announced plans to install and test an electromagnetic railgun aboard a joint high-speed vessel by fiscal year 2016. The Navy had previously tested a railgun in the late 2000s under the project name Velocitas Eradico, Latin for I who am speed eradicate.
Oh, getting all warm and tingly.
The railgun was capable of launching a 7-pound projectile at hypersonic speeds up to 2.4 kilometers per second, and the final operational system will be able to fire munitions up to 110 nautical miles. Using an electromagnetic force known as the Lorenzo force, the railgun rapidly accelerates and launches a projectile between two conductive rails and at greater speeds and ranges than conventional weapons. The effect is similar to linear induction motor roller coasters. And because it launches projectiles at such high speeds, a high explosive payload is unnecessary. And because a railgun precludes the need for explosive munitions, the Navy saves some mucho dinero. The Navy will use the railguns for a variety of threats, including enemy warships, small boats, and aircraft, and as a countermeasure system against incoming missiles.
That's all for this week's update. Join the conversation on Twitter, Facebook, and LinkedIn. You can also check out past episodes at ecnmag.com. For the ECN channel, I'm Casey Panetta, and this has been your Engineering Update.